when you have a polynomial equation, such as 1x squared minus 8x plus 20, that polynomial has roots. In this case, it has 2 of them. And calculating out the roots requires quadratic formula, most likely. But sometimes you're asked not just to find the individual roots, but to find, for instance, the sum of the 2 roots, or the product of the 2 roots. And there's a shortcut, and finding out the answers for things like sum of the roots, product of the roots, and other combinations of roots, use something called Viates Formulas. To see the relationship, you can multiply. Imagine the 2 roots are called R1 and R2. Then the polynomial could be factored to x minus R1 times x minus R2. And when I multiply this out, R2x, R1x, plus R1, R2, I'll write it like this. And what happens is that this b term ends up being negative sum of the roots, and the c term ends up being the product of the roots. So coming back here, negative 8 is negative the sum of the roots. In other words, 8 is the sum of the roots, and 20 is the product of the roots. So you do have to change this sign. Now that's if there's no coefficient in front of here. If there is a coefficient, and it's like the same question but has a coefficient there, 2x squared. Well, if you divide everything through by 2, you'll have an equation with no coefficient out here, but now you'll have 16 over 2x. I'll leave it like that. So the sum of the roots, or negative sum of the roots, is equal to negative 16 over 2. So it's still root 1 plus root 2 equals 8. And R1, R2 is 40 over 2, which is 20. Now to generalize this, we can say this, that the sum of the roots is equal to negative b over a. And the product of the roots is regular c over a. I like to write it that way. It is also true that like b over a is equal to the negative sum of the roots, while c over a is equal to the regular product. These say the same thing. It depends on how the question's worded, which sort of way you're going to think about it. Now for cubics, imagine I have 3x to the third plus 5x squared plus 18x minus 14. This thing has 3 roots. And you could derive the formulas a similar way. It would become this pretty complicated expression when all the like terms are put together. But you'll notice that again we have the middle term, or the second term that is the negative sum of the roots. And the last term is still, well, it's not exactly the product of the roots, it's the negative product of the roots. And this other term is kind of strange. So let's summarize and show you how to use this and what it all means. So our equation again was 3x cubed plus 5x squared plus 18x minus 14. Now, the sum of the roots is still going to be negative b over a. That's true for any polynomial. So in this case, it's negative 5 over 3. But this 18 and the 3 is actually involved there also. C over A is equal to, get this, it's a mouthful, R1, R2 plus R1, R3 plus R2, R3. That's called the sum of the roots taken 2 at a time. So there's 3 ways to take pairs of 3 roots. And if I add those together, I would get C term divided by the A term. So in this case, I don't know R1, R2, or R3, but this complicated expression, R1, R2 plus R1, R3 plus R2, R3, that is going to be equal to 18 over 3, which is 6. That one is not the opposite. And finally, now this, you think of this as the product of the roots, but we could also think of it as the sum of the roots taken 3 at a time. But there's only one way to take them 3 at a time, so we only get one expression. That's going to be negative d over a. So it alternates, and the general rule is that if the number of things at a time is even, you're not going to switch the sign. But if the number of things at a time is odd, you are. So it's regular 14 over 3. We can use these rules to answer questions like, what if the 3 roots are 2, 3, and 5, and the polynomial is x squared plus x cubed, plus bx squared plus cx plus d. So implied here is that a equals 1. Well, b is the negative sum of the roots. So the sum of the roots is 10, so b is negative 10. C is the positive sum of the roots taken 2 at a time. Which is positive 2 times 3, which is 6. 2 times 5 is 10, 3 times 5 is 15. And we end up with 31. And that's going to be our C term. And the D term is the negative sum of the roots taken 3 at a time, otherwise known as the negative product of the roots, which is negative 30. So this polynomial will be x cubed minus 10x squared plus 31x minus 30. Now the pattern continues even for like 4th degrees. So in this case, the sum of the roots will be, again, negative b over a. The sum of the roots taken 2 at a time, and there's a lot of them, I think there's 6 pairs, R1, R2, R1, R3, R1, R4, R2, R3, R2, R4, R3, R4, 1, 2, 3, 4, 5, 6. That's going to be regular C over A. The sum of the roots taken 3 at a time is going to be negative D over A. There's only 4 of those. R1, R2, R3, leaving off the R4. R1, R2, R4, leaving off the R3. R1, R3, R4, leaving off the R2. R2, R3, R4. Again, this negative D over A can be calculated easily, even though the individual roots are really hard to calculate. And E is the sum of the roots taken 4 at a time. That can only be done one way, so it turns into the product of the roots equals E over A. So notice how the sign doesn't change, but for cubics it did, and for quadratics it didn't. So that's how you can relate the roots to the coefficients of the polynomial to answer questions like what are the sum of the roots, or what are the sum of the roots taken 2 at a time or 3 at a time. The hardest part, or something that can happen, is that you might need a negative in there. So the general rule is if you're doing sum of roots an odd number at a time, you do have to change the sign, and if it's an even number at a time, you don't have to change the sign.